Thank you, everyone. I'm going to talk about scalable machine learning pipelines using Argo Workflows. I recently just talked to a few folks, and it turned out that there's like maybe a little bit confusion around Argo. So it's like a bunch of umbrella of projects. I'm going to talk about the workflow component. So not Argo CD. I'm not talking about GitOps and all the other stuff. So it's like the workflow orchestration part. I just wanted to highlight that. OK, so a brief introduction. My name is Antal. I'm the team lead of the infrastructure and the microservices team at Colossyan. And I've been in this company for 2 years now. We deal with a lot of machine learnings, model trainings, these kind of things. So our use case is based on that. I'm going to talk a little bit more about that. Yeah, basically that's my background here. So about the workflows. Our use case was basically something like a batch-like orchestration of loosely coupled steps. We can talk about a bunch of scripts, Python scripts, for example, or Bash scripts, a lot of container-based workloads. This is mostly for machine learning model training, or for example, asset processing, different actor footages, for example, and all other kind of things. We've been heavily invested in Kubernetes, so we really wanted to take something that is very cloud native. So it's not something like they have a Kubernetes support, but it's Kubernetes is a first-class citizen, and we really wanted to invest in a good DevOps experience that we've seen is a big obstacle around managing your workflows and steps and all kind of things. Back in the day, so we've had like an extensive and thorough review and research about all these engines, and we briefly took a look at about some of the major parties in the field. I'm just gonna, so this is like a random list that I found from 1.5 years ago. Obviously, we take a brief look at Airflow, Dexter, Perfect, so these kind of like the major players in the workflow orchestration area. Those are mostly like, for example, Airflow is a great tool, but it has a really great Kubernetes support or Kubernetes executor, but it's not coming from the cloud native space. It just has a Kubernetes support, and we really wanted something that has that is based on Kubernetes. Other things like we wanted our primary use cases is machine learning, so we also take a look at Kubeflow. I'm going to talk a little bit about that later, and obviously there are hundreds of smaller projects that have some kind of niche use cases, but in the end, we basically the cloud native, the good GitOps experience were like the major 2 factors that we wanted to pick on Argo Workflows. Yeah. So please raise your hands if you've ever used Argo Workflows or know that component. Oh, OK. So yeah, I'm going to. I expected some kind of this, so I just wanted like a few sentences about the project itself. So a few like basic concepts around every workflow orchestration engine is that you have some kind of steps. It's kind of an action to be taken, running the script, even Bash or Python or any kind of things. If you have a container, then run that container. So everything that Kubernetes, for example, can understand. Argo Workflows is a very cloud-native tool. It uses CRDs. We have the workflow template, which where you can actually create a list of steps, even a DAG-like structure, and how to run these containers. And you can create variables that will be substituted when you run that specific workflow. And the workflow CRD itself is actually the set of pods or like the structure that should be run one after each other. The Argo Workflows provides you with an Argo Workflow server, which runs as the controller, basically. So it reconciles all the CRDs to these actual workflows, the pods, or whatever you want to create. And it also has a really nice REST API that you can actually call and create these workflows directly in the cluster. And it has a good UI. That's also a nice thing to have. OK, so here is a huge list of all the features that it provides that were really could be important for us later. I will talk about that as well. It has a really great artifact support, workflow templating, all the schedulings, like using cron. It has a good API. all these kind of things, step and all the other level of inputs, outputs. It supports all kind of Kubernetes Kubernetes features like affinity toleration, selectors, volumes, all these kind of things. The authentication part, that it supports single sign-on, this also came handy to us. And basically, if you just click on the links and you check the major use cases, it will says that it's basically used for CI/CD, data processing, infra automation, machine learning, stream processing, so these kind of things that requires steps, containers, scripts, one after each other. And obviously, machine learning is one of its primary use cases, so it wasn't like a really very new thing that we've tried to use it. Yeah, so I'm just going to show a few examples of how we used it and also some obstacles. So I will be a little bit less technical and more anecdotal, but if that makes sense, then I'm happy to talk a little bit about that. So what we came from is really, really far from the cloud native world. We have a few researchers, they had some Python scripts, and they needed us to, they handed us over, and they said that, we have these kind of programs, and, it's up to you how to automate it. So first we did, so we're coming from not even the Jupyter notebook world, which is just a bunch of Python scripts that we have to containerize. So it was a very long road to even get to a final container itself. This was the first workflow that was run, which was about like a few months of work. It doesn't seem really much, but it was a great deal of work for us. And it was just a very simple steps that these scripts pull some data from S3. We are using AWS. It does some work and upload these final outputs to S3 as well, even as an intermediate store or like the final models themselves. As I mentioned earlier, Argo Workflows, Argo Workflows has support for different kind of artifact stores. We experienced low performance when we used the native Argo artifact store, so we implemented our own download, upload steps, as you can see here. The second bubble is the download, and the last lines are the upload steps after the workflow actually run. So all these machine learning related use cases are well known, so industry-wide. If I will share the slides, then you can just click on, for example, two of these links. It's been used extensively, for example, in BlackRock or Vault, or all the other things. These are actually from the Argo Workflows website, so you can also see some examples there. Yeah. Our path to this initial integration was a very bumpy ride. I'm not really going to talk a little bit more about it. This is a meme that we sent to each other in the early times when we had like the first run. So we kind of scared each other with these kind of charts that happened, and we tried to figure out why a certain workflow would not work, but it's working now. One of the complexity, it's why we had really big struggle, is that it's hard. I don't know if you've ever orchestrated like scalable workflows that uses GPUs on Kubernetes, but they are like not an easy ones with all the scheduling stuff. So that's why I've seen a lot of these charts. Okay, so a few features that we've been using extensively are the following. So basically, we do have a lot of manual triggerings and manual model trainings. So we use the Argo Workflows UI extensively. These are really great visualizers. If I have time, in the end, I can show you a few examples of that. We do have some webcam-based actor training as well. These are all triggered fully automatically using the Argo Workflows APIs themselves. So we are also kind of using a fully automated API-based workflow as well. We use a lot of retriability. I will talk about that as well a little bit later. So if some of the workflows or some of the pods were failing, then you can have some conditions. For example, you can add an extra affinity or anti-affinity that you can retry your workflows or pods that might be better. We used the authentication part. It was really easy. It was kind of straightforward to integrate. It wasn't easy for us because we are not really into the auth world, but it comes really handy when we check, for example, who submitted the workflow, so it's good for audit purposes as well. And obviously, we were heavily invested in the cloud-native ecosystem, so the monitoring of these workflows are really great. We've been using Loki, Prometheus, Grafana, among others, to actually monitor these workflows, to get their outputs, and even we have proactive alerting when it comes to the actual utilization or stopped workflows or these kind of things. Yeah, so these are some of the examples that we encountered. These were the obstacles. Some of them were quite annoying. I'm trying to have a few examples of what not to do when you're using Argo Workflows, let's say. Obviously, some of them are related to GPUs and machine learning workflows, but some of them could just be understood as well. So we're using AWS, and we're using AKS. We've been using it for 1.19, I think, and they have GPU support around 1.20, like the good GPU ones. And since we've moved with Argo Workflows to Kubernetes, we've encountered a lot of intermittent termination, let's say. We've been investigating for like 6 months until we find out about these features, about these machine learning training sometimes being interrupted. This feature calls AZ rebalance. So it's really great if you have a few web servers and you have an auto-scaling group in AWS, because it tries to balance all the nodes between the availability zones. So it's really great if you have a few web servers. Then you can just reallocate them between the nodes. So it's great for interruptible workflows. But for batch-like workloads, it's not very great. So if you can see, for example, we have these 4 nodes. All of them are GPU nodes. They have trainings. Our trainings are usually like days long. So let's say that the one in the AZC, so the C availability zone, has been running for like, I don't know, a day and a half. And the one in the A availability zone just finished. So what will AWS do in this case? It will just interrupt the one in C and reallocate the node in the A availability zone. We've been investigating this a lot. We've used all of Kubernetes features, priority groups, schedulings, eviction protocols, so whatever we could use. We thought that it was something that Kubernetes do and related to the GPU workloads, but it was an AWS feature. So that was something that I think cost hundreds of dollars to the company, but that's another stuff. So we do have a lot of CRDs. That's really great. So you can actually create your resources declaratively. It's so great. It comes really handy. We're using Flux, which is a bit ironic because we're talking about Argo. But so in Flux, we store all the manifests in Flux. But as I said, there's a lot of features around workflow templates and arguments and how to provide them. And because of this very flexible templating language, you can reuse the templates. For example, if you have like an S3 upload or download step, you can use it for all your other workflows. But what if you have a step that has a new argument? You have to write all these arguments across all of your workflows that uses that. And it's really not great. This is a pull request from exposing a single argument that we use is just an extract from it, or like the first few lines. You don't even have to see it, but so it doesn't matter. The main point is that you can expose a new parameter in one of the scripts or in one of the environments, and you have to also pass that argument to all the other workflows that uses it, and it's just, it comes out of hand if you had a lot of workflows. This is true if you have like individual arguments or individual parameters that you can pass to the workflows, and you can obviously mitigate it, for example, using a single input argument, for example, like an M file or something like this, so you don't have to add this manually one by one. But in the beginning, it seemed like an easy way to just add new parameters. But it's it's a little bit annoying. And obviously, if you just miss one of these, then your new parameter will not be passed down to that actual containers, and it will be really annoying to actually debug why a certain parameter that was set was not reflected on your actual workload. It might happen that it will only be realized in like days later if you have like a complex machine learning training, for example. Yeah, the other things are artifacts. So I've talked about that we had some problems regarding the native artifact store. So we've been experimenting a lot with it. First, we just used basically a manual S3 download upload step. It has its own flaws. It's not nice, but it worked for a long time. But we wanted an upgrade. We wanted something that is more flexible or more performant. We've been trying to use some of the cloud-native storages, but they seem like an overkill, just maintaining a min.io or something really complex to live in the same place in the cluster. We also used some S3 drivers, experimented with it, but it even had like a lower performance compared to the others. We're currently using a network file system-based AWS AFS implementation that come really handy. Actually, all these heavy machine learning workflows where you have a lot of small files that you have to push through a network because of the optimization behind it. So it was really great to actually opt in. It had a good effect and performance on the actual workflows as well. You can also see this is an AWS cost about the AFS cost that we've just discovered that something's happened in the background. That's just something that we should keep at bay. Yeah, and I think this is the very important thing, that how to test your workflows. This is like, if you have a solution for this, then please found your own startup now. We do have a lot of issues, or had a lot of issues regarding your workflows. Yeah, as I mentioned, we've been using Flux. So usually all these workflow changes or introducing new workflows comes as like pull requests into our repo, which just works fine. You can check the pull requests, and you can approve it if you feel it's fine. But what about the checks? How do you ensure that what you've made, or for example, new parameter exposes, is going to work? So that's the problem. For all the other things that Flux gives us, for example, the image update automation that helps us releasing new image tags, for example, that's are just fine. So we don't have to manually do anything in the workflows. But this typical feedback loop that you're doing a pull request, you merge it, Flux reconciles the resources, and then fails to apply, or it applies, but there's something when you try to actually run that workflow. So it's like a really, really bad experience. So yeah, we've been struggling this a lot, and recently we've improved a bit on the actual DevX on this. I'm going to show a little smaller extract. I hope that it's somewhat recognizable. So it's we're using GitHub, and this is a GitHub workflow extract. So what to do with the Argo workflows actually. So first, the Argo CLI actually has an Argo lint command. So you can use Argo lint that actually checks your workflows, make sure that that the the CRD is compatible with it. We have a dev cluster where we can actually apply these resources, so we can make sure that the API server responds that the CRD is actually working. And we can actually run a dummy workflow. So we have a set of inputs that the workflow should run like relatively fast, about 15 minutes, where we can actually test that all the scripts and all the containers can just spin up and run to the end, and we can actually check the outputs as well. So that's like the bare minimum that ensured that these workflows are actually happening. The team did a great job when putting all this together. Haven't heard about the Argo lint before, actually. Yeah, so that's really about the core stuff. I wanted to show you a quick peek into what we're doing. It's not going to be like a live demo. I thought that starting a workflow and then finding the answer, you can check all of that in the Argo workflow side. I'm just going to show you a few things around this. So this is the Argo UI that you can check. We have a bunch of workflows. I showed you like these small examples of a few nodes. This is what a full training looks like currently. So it has a bunch of steps. You can see that some of these arrows that pointing towards are conditional steps that are skipped. So we're using a bunch of features that Argo provides. And it's really flexible. If you can get through to the, I don't know, hundreds of pages of YAML, but you will find what you're really looking for. Yeah, let me just, yeah, so here's the full workflow. OK, so I want to quickly show you, this is not something really extra. This is, as I mentioned, this is our Argo Workflows dashboard. It's all like the default Grafana dashboard. It's not really nice. I wanted to show you that there's currently not much workflows that we're running. There's been a few areas in the past when we've been running like 20-ish workflows simultaneously, which means 20 GPUs in AWS. But there's currently not much because we've just got through all of our backlogs and there isn't much training already. So yeah, basically that's. And something else that I can show you is basically how we're trying to monitor these kind of stuck workflows, for example. So we do have alerting based on these workflows, but that's not really important. It's actually what I wanted to show you is that we actually check for unschedulable pods, for example. This is important for us because of the GPUs. So for example, this is an example where there was a stuck pod or a stuck workflow for an hour and a half, and we had to investigate what was the underlying issue there. Basically these are the major things that I wanted to show, and I think we can have a Q&A now if you have any questions.
I'll kick off with the basic one then. So, you said that you like basically limit data size to something that can run in 50 minutes, and usually these workloads run for a day or so.
Yeah.
Right? How frequently do you perceive something failing at the day mark or something? Because we do have this problem that we have big data and we are limiting our data size, but with real data comes real problem.
Yeah.
Right? So what is your stand there? Are there any further steps that we're doing in terms of testing, or this is not that critical part?
Yeah. We used to have these kind of problems a few months back even. Since we have these same checks like the linters, the actual testing in the dev cluster, we had like it's really rare now that we do have this use case. We have this light avatar thing that so we do expect some kind of inputs, for example, like the web camera footages that the customers provide to our models that might be really something that we don't expect. So we do still see problems with that, but I think that's something more of a pipeline issue, that you test your pipeline well, or you have a really tough validation in front of your pipeline. So we do not really have that anymore.
Thank you. So I understand correctly, you are controlling most of that data that's coming in, right? Apart from
Yeah. Yes. So we thorough validation. Yes. Yeah.
What is the primary reason you are using Flux over other Argo-related products in the GitOps principle field?
Yeah. I should repeat the question, right? So the question was that why we're using Flux in favor of other Argo projects, right? Yeah. So it was so we've adopted Flux long before we've wanted something like a workflow orchestration engine. So we just there wasn't really like any big, I think, big reason behind using Flux over Argo CD in the past. I would say there isn't much now. I've been using Flux, so I'm not really an expert of Argo CD. But when it comes to workflow orchestration, there wasn't really something in the Flux ecosystem that would, really fit into the area. So yeah, we've been using Flagger, which is Argo rollouts equivalent, if you're familiar with that, because it really is compatible with Flux. But other than that, I have no preference between the two ecosystems. We'll see how it goes in a few years, probably. But yeah.
Yeah, that's absolutely frameworks. Later on, you will have other preferences.
Yeah, yeah.
Thank you.
Yep.
You mentioned during your presentation that most of your workflows are started manually, right?
Yeah.
Are there any workflows that start with an automated trigger? And if so, how do they relate to machine learning stuff?
That's a good question. So it's only very recent that we had a big enough research team to talk about this, for example, hyperparameter tuning or any things. Actually, I forgot to mention this, that we've been looking into Kubeflow and all the other things. Kubeflow actually uses Argo Workflows, its pipeline features. So it would be really like a clear transition over that. So it's only recent that we had like bigger problems to actually to think about. So it's currently now that we're using these kind of things. I don't have much experience to share at the moment, but yeah, we've experimenting with some bigger ML flows currently.
And also you mentioned that most of your infrastructure is in AWS.
Yeah.
So is the target for these train models SageMaker?
Yeah, that's also a very good question. So the question was about whether we use SageMaker or integrate with it. Currently, no. It's very tempting to use it. We are really we've been also taking a look at SageMaker 2. We are really afraid of the vendor lock-in, but obviously we're using a bunch of AWS features already. Yeah, we'll see about that. We don't have like a clear decision on that. We're just recently getting new fancy GPUs and stuff, so we'll see. But yeah, that's currently under debate actually. Yeah.
I know you mentioned that with the artifact upon downloading, you ended up with a network file system.
Yeah.
It's like I don't know. It's just for me a bit amazing, or I don't know, because for we also tried with NFS at first. It was quite slow for our case, and then we switched to some manually implemented ZSTD compressing up and downloading, and it was so much faster to do. We use Azure Blob, but same as S3.
Yeah, yeah.
I don't know.
Yeah, so actually NFS, as our experience, NFS was not really good with small files at first. But if you've been running the workflows for an extended period of time, that we do, because of the auto-scaling in the background of the network file system node. So it's like if you have a burst load, then it will be really slow for a few seconds or a minute. But after that, it will auto-scale in the background, and it will be much faster. So in our use case, it was faster. But probably in your use case, it's the better if you do that kind of way.
And then
Yeah.
you mentioned that you use NFS in favor of S3.
Yeah, so we're currently storing the intermediate artifacts in NFS that these individual workflow steps are using, and only the final outputs are uploaded to S3. And it was more performant in our case, yes.
Did you try S3 with multiple connections? I mean,
Yeah, so
thousands of connections.
yeah. We haven't really taken a deeper look at it. We've been suspecting that it's probably something with our S3 setup. We've tried to tweak with it.
What I measured is around 7-8 gigabits per second that I could maximum get for read from S3.
Yeah. So
and it's much more or less for NFS.
yeah. So
by my measurements, NFS is the slowest. Even you can use an EBS instance or an EBS volume, and if you put 4 EBS in an EC2 machine and have it in RAID 0 or RAID 1, I didn't remember. So where you duplicate stuff, then you will have better performance as well.
yeah. So I've expected the same. Our results did not show it, but we are no S3 experts, so that could be something with our configuration as well. So I did expect the same results as you mentioned, but actually we made a really thorough testing, and that's what we finally concluded. Obviously, it's not something permanent, so we also, these models need some rework in terms of how they operate, also into an upload and download to and from S3. So there are also a lot of room to improve.
You should check the EMR-based solutions and check the S3 connectors there. They are pretty fast.
Okay, thank you. Any other questions? Yeah, if no, then thank you.